Hey guys, Jindo Math here, and today we are going to talk about systems of equations. By the way, I help students conquer their SAT and ACT math sections. Subscribe to get free advice from someone who got a perfect 2400 back in the 20-teens and wants to help students perform at their best. So if you're like me and don't pay attention in school, you might ask, what is a system of equations? Well, it's when we have two or more equations that share variables, and the goal is to find values that satisfy all equations at once. Graphically, this would be where the lines or curves intersect. Solutions can be one or more solutions, no solution, or infinite solutions. So now I'll go over the three methods of solving these on the SATs and ACTs. And if you don't really care about understanding how the problems work and want a shortcut to the answer, I got you. Use Desmos. Back in my day, we would have to convert the equations into graphing format. But today, y'all got it easy. Just plug the various equations into Desmos and find out where the lines intersect. You literally can't get this wrong unless you make a typo, in which case, I'm sorry, you deserve it. For example, let's say we have y plus 3 plus 4x equals 5, and 2x plus 23y equals 12. Plug them into Desmos, find their intersect at 0.37778 and 0.48889. This is literally all you need to do for systems of equations. If you are stressing for the exam, feel free to end the video here because the rest is for the curious ones who want to understand these at a deeper level. The one thing I'll add is that it is still going to be helpful to understand how to solve these equations without a graphing tool because you may want to apply these concepts in various other problems. Plus, sometimes it may be faster. So without further ado, let's talk about the substitution method. The substitution method works best when one equation is already solved or easy to solve for a variable. The steps are as follows. 1. Solve one equation for one variable. Plug that expression into the other equation. Solve for the remaining variable. Then back substitute to get the other variable. The pros are that it's clean and simple when variables are isolated and great for plugging into word problems. The con is that it can get messy if both equations are complex. So here's an example of a problem where the substitution method works great. X plus y is equal to 1, 2x plus y is equal to 3. Solve for x and y. We can solve the first equation for y since we see that the second equation also has y by itself with no coefficient. We get that y is equal to 1 minus x. Then substituting this into the second equation, we get 2x plus 1 minus x is equal to 3. X plus 1 is equal to 3, so x is equal to 2. Back substituting this back into our first equation, we get that y is equal to negative 1. The last method we'll go over today is the elimination method. These are best for when equations are nicely lined up. The steps are as follows. Multiply one or both equations to get coefficients to cancel. Add or subtract the equations to eliminate one variable. Solve for the remaining variable. Plug back in to find the other. The pros are that it's very fast when the coefficients are clean, for example when they're same or opposite, and it helps you to avoid messy substitutions if equations are not isolated already. The con is that it can involve multiplying both equations and it's easy to mess up signs when subtracting, and this leads to silly mistakes. So here's an example problem where the substitution method works great. We have x plus 2y is equal to 6, 2x plus y is equal to 3, and we want to solve for x and y. So first, let's multiply our first equation by 2 to get 2x plus 4y is equal to 12. Then, subtracting the second equation from the first, we get the x's to cancel out, and therefore 3y is equal to 9. Therefore, y is equal to 3. Plugging this into our first equation, we get x plus 6 equals 6, so x is equal to 0. In summary, use the graphing if you're not confident in your skills. Use substitution when variables are already isolated and elimination when you can clearly see a clean way to isolate variables. Watch out for these common mistakes. Sign errors in elimination, forgetting to back substitute to find the second variable, misreading variables or switching equations, misreading the questions. Sometimes it might ask for x minus y or x plus y or x or y individually. Make sure you know what the question is asking for. And finally, graphing incorrectly. Again, if this happened to you, you deserve it. Good luck on your journey, and remember to leave a comment if anything is unclear, and I'll try to help you out.